Among these, we have almost everyone read about the chirality around the carbon atoms. So that I am not going to discuss there. Rather, we'll discuss the chirality of different molecules like alene, binols, and these kind of things. Okay. So, so alene is said to be chiral when these group are different, means A does not equal to, sorry, D does not equal to E and A does not equal to B. And if you look the orientation of the different group around alene molecules, let's say D and E, they are on the screen, and A is on the back side of the screen, and B is on the front side. So now if I asked a basic questions that why this molecule is chiral, then we have to go to the basic understanding of or basic fundamental of chirality. So any chiral object, that is any chiral object will be non-superimposable with the mirror image. Non-superimposable with its mirror image. Here we'll see the what happens for the mirror images of alien molecules. For example, let's take it these ones. Let's say this is H and Cl, and these are H and this is Cl. So similarly, this is on the screen, this is on the front side, this is on the back side. So if I take a mirror image, let's say this is the mirror which is perpendicular to the screen. This mirror is the perpendicular to the screen. Perpendicular to screen. As a result, what will have this image? These are H, Cl, and this is the H, and this is Cl. Let's say one is the molecules and two is mirror image. Now, if I want to superimpose 2 over or 2 prime over 1, then what will happen? Let's turn it around. Then what will happen? Let's say here I am going to invert this. I am going to superimpose here. So similarly, this is the H here. This is the Cl here. C double bond C double bond C. Now this will get reversed. So here it is we have Cl H. So this part is not superimposing. So H will fall over Cl and Cl will fall over H. That is 1 and 2 is not superimposable. So using this, the core concept of stereochemistry, that is any chiral object will not be superimposable to its mirror image. That is, this alien is chiral in nature. Not alien, this alien is. So given alien is chiral in nature. If alien is chiral, given alien is chiral, then the next question is, so it is R or S? This is the fundamental question. So for the here I am showing the different types of alien molecules. So let's say this is given. We see that this does not equal to the equal, and this is also these two groups are different. So these are chiral. First point. If these are chiral, that is what? Due to chiral axis. Due to chiral axis. Now, so is it R or S? Next fundamental point. So there are many methods for arts and there are some trivial. So you have to remember, you have to look at along the axis, then you have to close your eye, you have to remember that which groups is along your right side or left side, blah blah blah. You should imagination, you should some force on your mind. But here I am showing one method that is very much easier. You don't need any imagination, you don't need any pressure on mind. That is very interesting method. This method was used first time by Professor P.S. Kelsey in 2004. That is, our job is that these sides, that is on the top and back, we have to move it towards the downside. So we rotate the molecules by 90 degree. That is, after 90-degree rotations, we will have these things. Here, this is the top group. How do I obtain top group? Because the symbol is telling. So this is below or down. Let's say this is down. And we see that this is right and this is left. Nothing. Just rotate the molecules by 90 degree. We have these things. So top group priority is 1, down group is 2. That's why see top is 1 methyl, down is 2 hydrogen. Right side it is again 3. So this is again 3 and this is 4. So this is the right. So see 1 to 2 to 3, we are finding that 1 to 2 to 3 is clockwise, counterclockwise, clockwise. Hence, it is S. Not only S, we have to SA means axial chirality. So this is the proper stereochemical description of the molecules. So beauty of this method is that we don't need any emphasis on our brain. We don't need any imagination. Just rotate the molecules and just proceed accordingly. Now you may ask, so if this is one isomer or enantiomer, it's another enantiomer will be its mirror image. That is this kind of things. So let us see the stereochemical description. We found that this is SA. It has to be RA. Now we'll see similar method. So this is the molecules. We rotate it these sides by 90 degree. So this is on the below side. See this symbol top and priority 1. This symbol below or down having priority 2. And this is on the right side. Priority 4. And this is on the left side with priority 3. So just put it them. So 1 top, this methyl, 2 down, hydrogen, 4 right, this one, and 3 methyl. So we are finding 1 to 2 to 3 is a clockwise. So its descriptor is RA. RA means it's R and AC for axial. With simple method, we found that one enantiomer is S and with a stereochemical description A, another is R with description again A. So this is the type 2. Here we see that this kind of molecules, basically this is called atropisomerism. We will discuss this atropisomerism in some dedicated class. So you see around this axis, we notice that on the top side we have nitrogen and COOH, and these two are same on the screen or display. And here see that these are on front side and these are on back side. So using the condition of axial chirality, we found that these two group are different, that is nitro and acids, and here also different. That's why it's a chiral. So this molecule is chiral because of this chiral axis. Now again, as this is chiral, we need to know the stereochemical descriptor. It is R or S. It's very simple. Just we will rotate this one was 90 degree. So this is the our target. So we found this is top with priority 1 and nitrogen will have more priority than carbon. This is below with priority 2 we find this is right with priority 3, and this is left with priority 4. Now we will use this 4 in the figure. See, 1 for nitro, 2 for acid, and 3 for again nitro, and 4 for again acid. So 1, 2, 2 to 3 excluding 4, we are getting counterclockwise. So this is also SA. If this is SA, this one, this have to be RA. Next, we'll see this is RA or not. This is one. So this is our target. Just rotate it by 90 degree. So this one. Look. Now top 1 nitro, below 2. This is acid. So this is acid. In bracket I am writing this. This is 4, this carbon. So this is on right, again acid, and this is nitro, on left 3. So 1, 2, 2 to 3. This is clockwise. These are called R. A for description, that is axial guide. So we find that this is also R in nature. Now the beauty method, again I am repetitively stealing without any imagination, any enforcement on brain. We are easily in a couple of seconds are able to say that these are the R or S. So this is example type 3, binary type of molecules. So as simpler, just rotate it to the downside. Now it is on the downsides. Top priority is 1 for OH. This is benzene kind of things. Second priority. Third priority is again OH. And look, this is on right side. This is right. And it is on left side. Left. Benzene kind of things. Again using 1 to 2 to 3, it is counterclockwise. So S enantiomer. If this is S enantiomer, then so if you take his one mirror image, so one is going to be S, so this one is going to be S, then you find that it will be R. So just do your job, it will be R. So just here we have again unfortunately repeated the same thing. So just you try with this will be R1. This is another type of things. So this is again, if you look along the axis, what we will find, this one, so being sp2 carbon atom, this COOH and this H on the same plane, and this hydrogen is now orthogonal to this, right? Means it will be backside of screen, sorry, and this will be on the front side. As a simple method, just turn it to the downside. Now look, top, this is below, so top is methyl, below is hydrogen, right side we can see with priority 4, that is nothing but hydrogen, and left side we can notice with priority 3, that is nothing but COOH. So 1 to 2 to 3, it is clockwise R enantiomer. If this is R enantiomer, again take it in mirror image, that is this one. So just make it 90 degree and put it on downside. Look, top. How much this are easier? Methyl, below, hydrogen, right side, COOH, left side, H. So 1 to 2 to 3, it is counterclockwise, and SA enantiomer axial. So this is 3 different type, 4 different type. Now look, here is a different thing. So here Similarly, this lone pair and methyl on the screen. Now I am going to add various type of examples with different molecules that have the axial chirality. Similarly, it is backside and these are on front side. Just rotate it, top with priority 1 below. So here we put methyl, it is hydrogen. 4 lone pair having its least priority on right side. So this is right side. You can see it. Left side, methyl. So 1, 2, 2 to 3, say clockwise. So R in and so here we have to take one thing, a very important note. If a nitrogen is given, then we have to consider the lone pair of nitrogen. We have to consider the lone pair of nitrogen in order to find out the stereochemical description. Stereochemical description. So students, so please do not puzzle if it is given like that. So for example, one molecule has been given in this format. This is methyl, and let's see, it was given like that. So just consider it the lone pair. Otherwise, you will remember it as achiral molecules. So this is a very important note. The fourth molecule is very much interesting. I put quite time here. First of all, see, it has been given just on your format. If it is not given on your format, for example, it has been shown in that fashion. Let's think that this is hydrogen, and yeah, this kind of things is here, hydrogen. So just turn it down, you will get these things by 90 degree. Now this is top side group with priority 1. This is below or down with priority 2. This is priority 3. The right side, this is priority 4. Left side. So just I put the cross that was used by Professor Colsi. It is not the Fisher position, just the cross used by Professor Colsi. So 1, 2, I can find 3 on right side and 4 on left side. Just go for 1 to 2 to 3. It is clockwise. Sorry, it is counterclockwise. Counterclockwise. Hence, it is SA. Look at another thing. Let's think these carbon are linear. Let's think we have a linear carbon and a side chain has been attached in that form. This is simple. Now, for alene, so it is orthogonal to each other. Orthogonal to each other means we have to make one twist by 90 degree around this carbon. If I put a twist by 90 degree around this carbon, what we are getting, C double bond C, if alene system. Actually, this will become, in reality, we will have this kind of bend. Just you think, you twist it, so it will be bent. That is, this molecule has inherent helicity. So the molecule is not only have a chiral axis, but also it have here around this ring, it have helicity. If you use a model, you can get it which type of helical is that. But as we don't have model, here we'll take the help of tricks. So if you find that this alene has a SA description, then the helix is going to be P. You have to remember this point. And if the allene is RA descriptions, it is going to be M helix. That is, if we have an allene molecules that has been connected by a linker, it will have both chiral element. That is very much important. Both chiral element. One is axial or axial chirality, and another is helical chirality. So these are very interesting point. So if you don't properly look at the molecules and the twisted structure, you cannot identify the helical structure inside it. Next, this is a different type. So if it is the molecule chiral, I told that if nitrogen is given in the molecule, just consider its lone pair. Just take the lone pair here. Now you compare along the axis, along this axis, on the above and below, this lone pair and Cl. So these are different, and on the back and forth. So this is back side, and this is front side. And on the back and front, these are also different. So this is chiral. These are chiral due to chiral axis. Then, if this is chiral, what is the stoichiometric descriptor? As you know, just rotate it by 90 degree. We have rotated. These are on downside. So we have two lone pair. So this top. So top having priority 2. So I should show the arrow not from this carbon but from this nitrogen, and this is below with priority 1, at chlorine has most priority. So just I put the cross, I put 2 on top, 1 below, then 4 on right, 4 on right, and 3 on left, 3 on left, just from 1 to 2 to 3, 1 to 2 to 3. It's counterclockwise. Counterclockwise. Hence, this is S, and with the descriptor A means axial. So this is another type. Now this is the type 8. Type 8, what is that? These total molecules, the molecular frame on screen or on display plane, and these behind the plane or back of the plane, and this is on front part of the plane. Just as we know, so this is chiral. Due to its axial chirality, this is chiral because of this axis, because one chiral axis is here around this one. So this is the chiral axis. Now we'll rotate the molecules to a downside, as we know. Just here, just partition it below 1, top 2, just put it here. So below 1, top 2, then it is definitely 3, as carbonyl has higher priority. 3 left and 4 on right. So this is 4. So 1, 2, 2, 2, 3 is counterclockwise. So it is SA. Again, you take it mirror image. So mirror, you put mirror where? You put the mirror on the screen. So basically, let's say these are the mirror on the screen mirror. On the screen mirror means this one again will remain on screen. So on screen mirror. So mirror on screen. And this back part would come to the front after image. So sleep, these are on front. And this part will go back. And we notice these are on the back side. So now how we'll find the steering wheel descriptor? We'll rotate it by 90 degree. Routine work. We have almost practiced 15 examples, and every example taking not more than maximum 1 minute to find the description. This part is 1, this part is 2. So this is on top and this is on down or below. So put it 1 on top, 2 on below, 3 on right, 3 on right, sorry, 3 on left and 4 on right. So 1, 2, 2, 2, 3. 1, 2, 2, 2, 3. It's clockwise. Clockwise. So we find that it was clockwise and its description was R, putting A to indicate that the chirality is axial nature. And previously we found that its mirror image was SA. That is, we have practiced. I shown the examples of different 8 types of chiral axis or axial molecules having chiral axis or axial chirality. Normally in exam, whatever, if they ask any question from axial chirality, this will be asked from this. So we may get the common questions. So normally, just have a look on the different question of different years. You will have the commons, the types. Another thing I should mention that as we are telling this is a chiral axis always, the axis is one dimension of nature. So that is, this chirality is also described as one dimensional chirality. One dimensional chirality. 1D in bracket. So if it is asked to align which type of chirality exists, it's a 1D chirality. In binol, 1D chirality exists. During actobisomerism, 1D chirality exists. So this is the thing. Now it will move to the different kind of chirality. Okay. So before that, let's solve these questions. So which of the following molecules is chiral? First on these two are same. As these are same, so this is achiral alene. Look at here. These are same. So this is also achiral. Here we find these two groups are different and these two groups different. So using that thing, this is a chiral. And we look these things. See, up to this was on alene. After that, it has been extended by 1. So if this become alene here, so what will happen? Let us draw that. Cl H double bond C double bond C HCl. It means that these are on plane and this is back and front. Let's say these are on front side and these are on back side. As we are extended one more double bond, so again twist by 90 degree. Again twist by 90 degree. If we put again twist 90 degree, the back side on the that is present on the back side, it is coming on the plane. So C double bond C double bond C double bond C. Here it is now on plane and Cl is on plane. ClH. That is these two substituent and these two substituents, they are on the same plane. On the same plane. That plane is nothing but the screen. So this molecule behaves as a alkene-like. Alkene. And alkene is what? Alkene is achiral. So this behaves as alkene. And alkene is achiral in nature. Achiral in nature. Now here I am to point out a very interesting information. If we have consecutive or directly attached odd number of double bond, we have directly attached odd number of double bond, it will be like alkene. And if it is even number of double bonds, it will be like alene. And this should be very much interesting information you should keep in mind, because this may be asked. Mistakenly, we can think this molecule as chiral, but these are achiral molecule. Achiral. But the logic in short logic, odd double bond, odd. Next. So far we have discussed it's a planar, it's a one-dimensional chirality. Here I will discuss about now different chirality. That is a chirality along a plane. So what does a plane? A plane means, let's say this is a plane. A plane always have two sides. One is back side. Let's say this is the back side of the plane, and maybe I can be overwritten again. Let's say this is the front side of the plane. If the two sides have two different chemical environment, that is called chiral plane. So I have to find a molecular plane, and I have to notice that around molecular plane we have two different chemical environment or not. So here we just try to understand the molecules. This benzene ring is perpendicular to the screen. This is perpendicular to screen. I should write it here. This is perpendicular to screen. This is the first half, that is on front side, back side. So if screen is a plane, on the back side of the screen, of the plane of the screen, and the front side of the screen have two different chemical entity. Back side of the screen don't have any bromine environment. Front side of the screen have bromine environment. That's why this molecule contain one chiral plane. One chiral plane, because of what the molecule is chiral. If it is a chiral, then what is its stereochemical description? It is R or S. To find out that, we have to find out one atom that is called pilot atom. So what is pilot atom? Pilot atom is first out of plane atom. First out of plane atom on the preferred side on the screen. On the preferred side of the screen. Sorry, on the, of the plane. So see, this is the first out of atom. This carbon is out of plane. This carbon is out of plane. The preferred side is the left side, because bromine is on the left side. So this atom is the pilot atom. Pilot atom. Again, I am telling, just if we make a line here, so this is the preferred side, huh? Preferred side. Preferred side. So we have two out of plane atom. First out of plane atom, this is this carbon, and this carbon. But this carbon is on the preferred side, so this is the pilot atom. And why it is called pilot atom? You look at the here. So normally pilot sits here, and this is the plane is moving on this side. So pilot is here, means on the plane or molecular rack, sorry, on the plane, yeah, plane, and pilot is quite above. That's why it's a molecular plane, and the pilot is here. That's why pilot this is called pilot position or pilot atom. And if this is the pilot atom, so this is called priority 1, and this is 1 by default. This is 2, and as this is 2, instead of this carbon become 3 as bromine is attached to this. So we are finding 1 to 2 to 3. So this fashion 1, 2, 3. So this is clockwise. Clockwise mean this is R, and P. P means it's a planar chirality. So first one we'll look at pilot atom. Then if pilot atom is 1, next to the element to pilot atom is 1, then it will be by default 2, then it is 3. Look, these two molecules, if it is R, these two molecules is chiral or not? Chiral or not? Our answer is yes. Why this is chiral? Because both the molecule has a plane. Around this plane, the chemical environment are different, because here in these sides, in these sides, no COOH. On these sides, but here we have COOH. So these two different chemical environment around this plane, the mentioned plane. So this plane is chiral. So this is chiral plane. Similarly, this is also chiral plane. Now, so what is description? Is R or S? Actually, these two are the mirror image to each other. Just put a mirror here. Let's say these are the mirror. So one is mirror and this is image. So these are the pilot atom. So this is the why pilot atom. This is out of plane. This is out of plane, but the preferred side is this one. So this is the pilot atom. Similarly, this is the pilot atom here, as this is the first out of plane on the preferred side. This is the preferred direction, so this is the pilot atom. This is the preferred direction, so this is the pilot atom. If this is pilot atom, so it is 1. So this is 1 by default connected 2. This is 2 and 3 in this sides and 3 in this sides. So look, 1, 2, 2 to 3, and here 1, 2, 2 to 3. So it is clockwise. So this is called RP, and this is counterclockwise. These are called SP, right stereographic distinction. Even here also notice that these two are different. Just one is S and the other is P, is mirror image. So what we resolve now? If the question is given with this kind of molecule, basically these molecules are called answer compound. Answer means bucket. It looks like a bucket. This looks like a handle, and this the things where the materials are put. And these are called the cyclophanes compound. Anyway, we will not worry about this name. So if this kind of compounds are given, and if it asks this is chiral or not, then we'll try to find a plane where these will have two different chemical environment. If we find that the both side of the plane is different chemically, then the plane is said to be chiral. As this contain a chiral plane, so this molecule will be chiral. Now to find out the stereochemical description, we have to check whether this is RRS. Then we have to find out the chiral atom. So what is, sorry, pilot atom. So what is pilot atom? Pilot atom is the first out of plane atom on the preferred side. This is very interesting, very simple. Routinely question is asked from the axial chirality, planar chirality. So I told initially for axial chirality, the axis is one dimension, that is called one dimension chirality. Here it's a plane. So plane is nothing but 2D. Plane is two dimension in nature. So this is called 2D chirality. So planar chirality is also two dimension chirality, 2D. So if it is asked, this molecule is which kind of chirality, only 2D. If we are not familiar with this kind of term, we may miss the questions. that is the cyclophane. If it has the actual chiral plane, that is two dimensions, so it is 2D chirality. ANSA compound, this kind of things. It has a chiral plane that is two dimensional, that is 2D chirality. So we heard about or study about the axial chirality, then planar chirality, then we will move to the different thing, helical chirality. So helical chirality means very easy. Yeah? So if we keep on adding helix, one benzene, one by one, so it will turn into helical nature. We are all about aware about helix, like DNA, we know this is helical. So keep on adding the benzene, it will be helical. So what is, will not do details that much, but so top group is called priority one. So top priority one and below priority two. Now go from 1 to 2. If this is clockwise, we'll tell them p helix. If 1 to 2 is anti-clockwise, we'll tell that as m helix. Okay, so this is 1 at the top, this is 2, that is below. We'll go 1 to 2 along the molecular axis, not in this way. So 1 to 2, here we find this is clockwise. So this is P. Here also the same thing. This is 1, this is 2. We'll go from 1 to 2 along the molecular axis. So this is again clockwise. So this is P. So if the question is asked from chirality after this discussion, you will easily do the problem. It will be asked either from, if it is a very easy question, it will be asked from the carbon containing chirality, just for different group. It is quite complicated. It will be asked from the either helical chirality or axial chirality or plane chirality. You can do the problem. Easily solve the problem. Now I'll move to, not now, in the next class, I will move to different topicity kind of thing. Topicity, different phase, rephase, psi phase, or this is a diastereotopic phase, or homotopic phase, or enantiotopic phase, these kind of things. A lot of questions asked from the topicity, and also we'll use some tricks also next classes on topicity. Once that is done, the topicity, then in third part, we'll move to the different conformations of cyclohexane. That is also interesting. So if we cover up the stereochemistry, I am planning to do 4 classes total. If you cover up the stereochemistry with this kind of way, so whatever the question is given to you, we'll have an idea to do this. Next, we'll find stereochemistry in spectroscopy. That is also interesting. It is being asked nowadays frequently. And after that, what we will do, just we will do the survey of different book, like very important book like Clayden, Carothers, Carey and Sandberg. From these books, the questions are routinely asked. So this is the way we will proceed. So thank you for your attention and patience. Thank you very much.